So hi everyone, my name is Julia. I'm a software engineer at Moniz. Also one of the few people, as I see, who are using the amazing design of DevOps for their session. Now, before I start, I actually want to give credit to my wonderful colleague, Dersh. Dersh is an engineer and an architect. We work in the same team, and he has worked the most with the solution that I'm going to present now. Now, what I'm going to be talking about is the result of some month of exploration of Facebook's GraphQL and Atlassian little library called Braid. At Moniz, we are searching for ways to improve the communication between our backend microservices cluster and our mobile and web applications. And I want to propose an architecture which will hopefully work better than your usual RESTful APIs. Now, a little bit about Moniz. We are a banking app launched 4 years ago in 2015. And after 4 years, we just reached a huge milestone, 1 million signups. We serve both private and business customers. And yeah, really love working there. Now, if we look at the backend, then 4 years ago, the first version of the product was running on 2 services, and they were built by 2 backend engineers. Now, 4 years later, we have almost 50 microservices, and I don't really know how many backend engineers. I kept thinking every day that I should count them, but then I forgot. Anyway, it's about 30 to 40 people. Spread across 3 offices in Lisbon, Tallinn, Estonia, and London. And so most of our microservices are stored in Docker containers and pushed to live. And everything is in the AWS cloud. So, of course, building 50 microservices by tens of people, some problems will arise which you need to tackle. Now, I will talk here today about solving 2 problems. Oh, okay, sorry, forgot. Our goal is to build the platform that will be ready to serve 1 million simultaneous users. So that's a very huge goal and hard to reach. And so the 2 problems that I'm going to address today is having heavy endpoints and using a gateway API for communication between the microservices cluster and web and mobile applications. So what is heavy endpoint? A heavy endpoint is probably familiar to anyone who is building for mobile applications. And it's an endpoint that returns a lot of data, too much data. And usually the reasons for this are historical. So it starts this way. You launch your first version of your microservice, and it has this beautiful endpoint, and it returns 5 fields, and everything is amazing. But 30, 40 versions later, the same endpoint, it might not even do for the last version of the app what it was doing for the first version of the app. And so it returns data that has to serve the very first version if you still have users using it, and the latest version. And this is just, this can become a mess, and this endpoint can return half of the database, as we're joking sometimes. So this is definitely something that we want to avoid and want to address if we feel that it's happening. Now, the second problem, the second challenge, is having a gateway API. And what this is, when I am saying gateway API, is this main API that communicates with your mobile applications, and it, for example, receives a call, a request from mobile, and then it sometimes processes it, sometimes forwards it to your cluster of microservices, and then accepts the response from them, again processes, and returns back to mobile. Now, having this gateway API can result in many people wanting to commit there. And this can result in miscommunications between developers. You are touching my part of the code. No, this is mine. And some merge conflicts. So we'd like to address it. When we were thinking about how we could improve the communication, the very first technology that we stumbled upon was GraphQL. GraphQL was developed by Facebook in 2012, and they released it to public as an open source in 2015. I'm sure that lots of people that know it. Actually, how many people know what GraphQL is? Yeah. So GraphQL is this graph query language, and it allows you to communicate with your backend in a more efficient way, in a more usable way, I would say. And it's a really, I think mobile engineers would understand the benefit of it the most. But it's the backend engineers who have to actually build it for the mobile. Now, GraphQL is language agnostic, so if you have your microservice written in Java, then it won't, and you add a GraphQL Maven dependency on your service, it won't just know about your objects and how they are related. So you actually have to define a schema. And you can see on the very left, you can define types, which means objects. You define the relations between them and how you can query these objects. And this is all called a schema for GraphQL. And then when you query it, so in this example, we query card with some ID, you can define exactly what fields you want to be returned with your call. So if card has 5 fields, in your particular one of the calls, you can say that I want only to receive ID, status, and type, and this is exactly what will be returned to you. Not more, not less. And this is a very powerful tool, which was actually, it's quite famous, and a lot of important guys in the software development world use it. For example, Facebook themselves, and GitHub, and more. You can see you can check it on their webpage. One more thing I want to mention for people who are not familiar with GraphQL is that it also has this interface which you can. Where you can play very easily with your endpoints. And it's in your browser, and you can just query your endpoint in a browser, which is super nice. Also want to mention that all GraphQL requests are post requests. So in the body of your post request, you define whether you want to get the data or mutate the data. So that's about GraphQL. Now, let's have a look at how our current architecture with our microservices looks like. So we have the mobile apps, which send and receive data from this gateway API, which exposes the RESTful API. And that gateway API, as I already mentioned, forwards the calls to the cluster of microservices. I was too lazy to put the arrows both ends, but I guess you understand that it also receives the data back and sends it back to mobile apps. Now, if we were to switch the REST API to the GraphQL, then this is how this new architecture would look like. And actually, again, the biggest benefit would be for the mobile application engineers. Even if you replace REST with GraphQL only in the gateway, this already would improve their lives and will help eliminate the heavy endpoints. But in this example, we can also replace RESTful with GraphQL for other microservices, and we can actually use both inside the same service. And this is also a very interesting observation, and it's really cool that you can employ both in your application. This would be useful if you are in the process of migrating from RESTful to GraphQL. Okay, so this looks nice, but we started to think, can we do something else? Because we were in this exploration mode. Can we maybe make life easier for backend engineers? What other tools and libraries are there which can help us build even a better microservice and infrastructure? So we started to think that, oh, it would be so cool if we could take the schemas from separate microservices and kind of stitch them together, put them to one, and then query the data in the same way as GraphQL allows us to query the data within one microservice. And again, receive exactly what we need, not more and not less. And this is when we found a little library built by Atlassian called Braid. And what Atlassian promises us is that, hey, you can use GraphQL in this way that you collect the schemas. And in this particular example, let's imagine that we have cards microservice having a card object and accounts microservice with accounts object, what a surprise. And cards microservice has this account parameter in it, so it's obvious that that it's an object from another microservice. So when we teach Braid how the schemas are connected, and we have to teach Braid, it doesn't know. It doesn't learn it itself, so you have to teach how the schemas are related. Then what you can again query it very easily. So here I will say that I want card with its ID, with its status, and I want its account, its status, and the list of its transactions. And then instead of writing a method in endpoint that you should divide this data, this query, and send half of the query there and half of the query there, Braid will do it for you. So it will query the data from two microservices, receive the answer, put it together kind of automatically, and send a beautiful response. Exactly as much as having exactly as minimum amount of data as you wanted. So yeah, it was when we first read about it, we thought this is a very powerful tool. We should try it. We should try it out, and we started to draw and kind of try to imagine how the new architecture could look like. And I'm going to introduce it now. This is how it looks like. Yeah, so easy. Beautiful. Minimalistic. Sorry. So actually, this is the slide for the mobile engineers. For them, nothing would change. They would still communicate with, let's name it, previous gateway API. But instead of it, we will have this Braid service which exposes GraphQL. Now, Braid service, it is more complicated. Now, Braid, it's all about instantiating the service, instantiating this one object called Braid. And what it does is that First, it knows about the microservices that are dependent on it. And then it tries to collect the schemas from the microservices. These are the schemas of their GraphQLs. And then it builds this thing which I call the schema of schemas, the master schema. And we provided the script which you wrote that teaches schema of schemas how the schemas of microservices have to be stitched together, how they are related to each other. You get this super smart Braid schema. Now, next step is that Braid creates these kind of fake proxy microservices. So we took, in the previous slide, you saw that we took schemas from 3 real microservices, and what Braid did is it created 3 proxy GraphQLs for each microservice. And they have 2 main objects, which are the schema and an HTTP client, which holds a URL of where this microservice lives for later querying. And all of this is one service. I just wanted to point it out that all of this is inside this Braid service. Now, the communication will then happen in a way that if we receive a request, if Braid receives a request, then schema of schemas will know, based on what you taught it, how to forward and where to forward the calls to. So it will send the part of the request, relevant part of the request, to the proxy account, to proxy card and proxy payment. And because these proxies know where to actually send the request to, they will send the relevant part of the request to the real microservice. Will be processed, will land on the relevant endpoints, and again, the data will be responded, and the schema of schemas will again stitch the answers together based on what you taught it to, how to stitch them, and will return the answer. So this is basically what we are trying to build, and we actually already started with the Braid service, but obviously, as you probably already understood, it's not live yet, so we're again still playing with it. So this Atlassian Braid is, I think, very experimental library. The current latest version, if you check on their Bitbucket, I think is 0.23. So it's really the cutting-edge technology we're talking about here. So obviously, we had to customize the way we instantiate Braid and add a lot of it to it in order for it to work with our cluster of microservices. And here are some findings. Now again, all of this comes down to instantiation of the Braid, instantiation of the schema of schemas. Once you have this object ready, it can serve all your calls. And we figured that it's complicated, at least for us. So it consists of multiple steps, and we have some code here, but it's really more of a decoration because the code is this enterprise level, everything is super abstracted. So in order to actually understand something, you would probably have to see a lot of our code, but these are the most relevant examples. So the very first step would be to collect the schemas from the relevant dependent microservices. Now, what can happen is we have to be ready for some of the microservices not being available at the time when we instantiate Braid. And it's because right now in Moniz we have 50 microservices, but very soon we'll have 100 or 200. we are deploying something to production basically every day. And this all is very dynamic. So we have to be ready that at the time when we instantiate our Braid service, something might be temporarily unavailable. Now, Braid works in the way that if something is unavailable, it just fails. So we cannot allow it. So we had to update or change the way our Braid is instantiated, or kind of twitch it to our needs. So what we will do is, if something is unavailable at the time of instantiation, we'll simply take the cached version of the schema, and it's stored in JSON. This is just a detail, but yes, the solution was we have to have some backup, because otherwise this house of cards that we built from different schemas and from their relations to each other, it will just break. So we have to have always some version of the schema of the microservice. It can be an older version. That's no problem. So I have some code in the middle there. Anyway, yeah. So this is important to have all the schemas of your cluster. And then when we have it, we are ready to instantiate Braid. And again, it's a process with many sub-steps, but I didn't want on this session to go into very much details of how we instantiate it, to just not bore you too much. But yes, this is one of the, again, important steps. So when you have everything together, you instantiate it, and finally, you have to store it in a singleton container. And this is because we want only one Braid instance in our microservice, in this Braid microservice. So everyone who call the Braid will call the same version and will call the same instance. Okay, so some more challenges which we addressed during this exploration. I already talked about the multi-step schema instantiation, but what is also related to is this self-healing process which we had to build. So now imagine that you were in the middle of instantiating Braid. Some service was unavailable. You used an older version which you had cached, but you still were using the older version. You want to use the newer version. So what we built is Braid would be constantly asking, "Am I okay? Are all of my versions available? Is everything new, or do I have something cached?" And if it has something cached, then it would try to heal itself by sending a request to the service, hoping that it will be stable already, get its schema, and restitch the Braid, and basically create a new Braid instance and replace the old one with the new one in your singleton container. So how this will be useful is that we won't have to push the reload button for instantiating Braid if something is now stable. Another challenge we had to address is this schema reloading. So as I mentioned, we have 50 microservices, and something is deployed almost every day. What if this update, something that went live, is related to the mobile application? So basically, what if the schema of that deployed microservice changes? We don't want to sit and constantly push the button with updating our Braid service. So we designed a process for automatic reloading. So when this microservice our idea is when this microservice will be deployed, after instantiation, it will send a request to the reload endpoint saying, "Hey, I have something new, please check it out." And then Braid will basically go and pick up the newer version of the schema, and again RESTish everything, throw the older Braid instance away, and put the new Braid instance inside the container. So this way, our Braid can basically live forever because we covered everything that can happen with it. Of course not, but we tried a lot. Now, challenges we are still facing. Well, what we haven't yet created the plan for is related to the fact that we work in a dynamic environment. Almost all of our services are behind the load balancer, and the load balancer defines how many instances of a service will be running, depending on the load. So what if we have 3 instances of Braid, and some microservice will send a reload request? It will land on one of the instances, but we need all 3 to be updated. Or what if we have something being deployed, and again, there are 3 instances of this service being deployed, and one of them is ready and has the new schema version, but the other 2 are not yet deployed and they have the older schema version. How can we tackle that? We don't yet have the exact tested solution, but we are planning to probably use some custom headers which we will be sending to the load balancer, and based on that, the load balancer will process and forward the requests to the relevant microservices. Okay. Now, if we come back to 2 problems which I mentioned in the beginning of the talk, will these problems be solved by the architecture, by the new architecture? And I think that I'm very sure that heavy endpoints will be a thing of the past for us if we actually do it. Having gateway API, well, not completely solved. We will still have this main API, which we will call Braid service, which will communicate with the mobile applications and forward the calls. But as we imagine it, as we are planning it, this service will need a lot less work from engineers. So they will have to commit a lot less to that service, and the problem will kind of be solved from another side. And this is because we will have these schemas which engineers in their service will define. So yeah, I think that both problems will be solved pretty well. Now, the final topic that I'd like to cover is migration. So again, we have 50 microservices. We have gateway API. How do you migrate this thing to Braid and to GraphQL? The short answer would be the process will be gradual. We will probably try using GraphQL and Braid on one service first, and then gradually remove the REST endpoints and switch to GraphQL. So again, has to be mentioned that it's very good that you can expose both RESTful API and GraphQL at the same time. Now, that's it for the technical part. The final thing I want to talk about is we are here with the Welcome to Estonia program. Moniz has a huge office in Tallinn, Estonia, and we have the booth right outside with the name Welcome to Estonia. We're trying to promote our beautiful, very cold, but nice country. It's not that cold, actually, you know what? And we have this Wheel of Fortune draw over there. So if you haven't yet been through the booth, then go and spin the wheel of fortune, and one of you will get a free trip. Yeah. Okay, that's it from me. Thank you. We have a lot of time for questions. Yes.
So, with Braid, is it like a library and you put all your code around it, or is it a framework that you had to modify to enable it to do all these other things?
It's just a library. It's just a Maven or Gradle dependency. You just install it and start using it, and build all your logic around it. Yeah. Yes. Hi. Sorry. Yeah. Do you mean that? Okay. So the question was, do we support different versions of schemas? And do you mean inside Braid service? Yeah. Yeah, absolutely. Do you mean that? So is your question, are we doing it now? Yes, we are doing it now, but not for all versions. At one point, we go so far that we have to say to some clients that, okay, this is a force update. Please, it's time for you to move on.
So you run multiple.
But we run multiple versions, yeah, at the same time, obviously. Well, the thing is, if you release a new version, and this endpoint that you have in, let's say, version 1, you still need to use it in version 2, but it has to be augmented a little bit. And that's exactly what GraphQL will solve for you. You will ask that in the second version, I need this data. Of course, the data cannot be completely different, but it can be a little different. So if you needed 5 parameters in the first version and you need 4 or 3 in the second one, then you can do it. Yes, yeah. Yes, hi.
So how does Braid do the downstream communication? So are your microservices RESTful and it knows how to talk to RESTful services only, or could they be Avro or some other kind of downstream service?
Yes, good question. I think that it depends. So your microservice, which is the real microservice, not the proxy, in order to communicate with Braid, it doesn't have to have GraphQL, because your Braid can just forward the calls without the proxy, just like you do it in your normal kind of life. Yeah, so it doesn't need to expose, all your services don't need to expose the GraphQLs.
So it translates the queries to REST APIs?
Yes. Okay. Yeah. There was another question in the back?
Yeah. So if you, with GraphQL, you can expose like an arbitrary graph of data in the database, right? So do you ever have like performance problems where some front-end person will start querying on some field that isn't indexed or something, and you can just kill the performance like that?
So the question was, what if one of the fields is not completely ready to be queried? What if it's not indexed and you don't want it to be? So the communication with GraphQL doesn't kind of touch the communication with the database. So if you write a database querying method which will return an object, you can say that you return object without this parameter, and then GraphQL will simply, first of all, it won't see, and it won't get it. And also, you define all of your fields in the GraphQL schema. So if you don't want this field to be queried, then you won't add it to the schema. Yes?
How have you implemented role-based access control so specific roles are only available for specific users? So I cannot query the balance of another customer.
We haven't thought about it. Yeah, I would need to think and then answer. Yeah, haven't got to that part yet, but I think that there are just multiple ways actually to solve it. You can define a schema per role, like an object which will be queried by this and this role. You can define different endpoints in GraphQL as well, I guess. This is just the first thought that came up to me, but don't have the good answer. Do you have a plan? Right. Thought that maybe you do. It's such an interesting question.
I have another question on which other GraphQL frameworks have you evaluated and disregarded, and why?
We have been playing only with Braid right now. Well, we also tried, so you can download the dependency of GraphQL in two ways. You can use this Java Kickstart, or you can just build GraphQL using more pure Java. But I think that I'm not answering your question right now. We haven't played with other libraries. Anyone else? Right. Okay. I think that's it then. If you want to talk to me more about GraphQL and Braid and Moniz, whatever, then just come. Okay. Thanks.